Hey everyone, Kyle here again, and today we're going to review how to solve multivariable equations. Let's first look at what we mean by solving in this context. If we have a problem which says, for example, solve for y, we want our end product or solution to look like y equals something else. Once the variable that we're told to solve for is isolated like this or by itself, with everything else on the other side of the equal sign, then we've successfully solved for that variable. One of the best ways to do this is to simply reverse PEMDAS, or the order of operations, in order to undo the operations on the variable that we're solving for. Although parentheses can be a bit tricky to work around, and we'll see this in one of the later problems. So first, anything that's added or subtracted from the variable that we're solving for can be quote unquote moved to the other side of the equation. In this example's case, we'll do that by adding 6x to both sides of the equation, thus manipulating the equation, but not changing the equality. Next, we'll need to move anything that the variable we're solving for is being multiplied or divided by. So we need to get rid of that 2. And we'll do this by simply dividing both sides of the equation by 2. That'll help us isolate y, and we've successfully solved for y. Using these techniques to manipulate multivariable equations can help you when you need to solve for a certain value with other limited data. In this example, if we needed the corresponding y values for multiple x values, we could use this new equation, which has y solved for, to much more easily solve for those y values or find the outputs for those x values, instead of doing this algebra every single time we need a new output. The same applies in other classes which use any mathematical formulas involving variables, like in physics or chemistry. All right, let's get on to the best part of these videos, as always, the practice problems. Pause the video and try these problems on your own. If you want extra practice, you can always try solving for other variables in the equation. I'll be here when you're done, unless you close the video, and good luck. Alrighty, welcome back. Let's go through these problems together now. So for problem number 1, our goal again is to isolate y. So let's start by moving the 3x to the other side of the equation. To do this, we'll subtract 3x from both sides, and making sure that we don't alter the equality, we'll get 5y equals -15 minus 3x. From there, all we need to do is divide everything by 5, and we'll get y equals -3 minus 3/5 x, and thus we've solved for y. For problem number 2, our goal is the same, isolate y. Our objective is a little trickier this time, and we'll see what happens with those parentheses. So you kind of have two options for doing this. If you wanted to reverse PEMDAS, then you could divide by 2 first, but that would give you some fractions that you'd have to deal with. On the other hand, you can instead distribute the 2 first and get rid of the parentheses, just giving you basically a bunch of addition. So 6x plus y is equal to 2y plus 8. This will help us more easily isolate the y variable now. So now we can just move all of our y terms to one side of the equation, and then move everything else to the other side of the equation. So in order to do this, I will subtract y from both sides of the equation, and also subtract 8 from both sides of the equation. And conveniently, that'll only leave us with one y left. So it'll be y equals 6x minus 8, and we've conveniently solved for y. For the last problem, you may recognize this equation or formula as the formula for the area of a circle. By solving for r, or the radius, we're going to derive an equation that tells us the radius of the circle based on its area. So in order to isolate r, we're first going to divide both sides of the equation by pi. That'll give us a over pi equals r squared. Now, the next thing we're going to do is we have to isolate r by itself. So we have to get rid of that exponent. And to do this, we're going to take the square root of both sides. You can't divide by r because that would give you r on the other side of the equal sign. You would have a over pi r equals r, and then you're not really isolating r. So we have to take the square root of both sides. And as a result, that'll give us the square root of the area divided by pi is equal to the radius. And again, that solves for r. That concludes our review on solving multivariable equations. I hope you have a great rest of your day. Take care and always ask questions if you have any.